In this session here, we'll be talking a lot about sharing code with Pulumi packages. So the idea that you can kind of package up best practices, policies, guardrails, governance rules and compliance requirements into shareable packages and distribute with your team. The person of the hour here is Ringo. Ringo works on our customer experience team as one of our premier customer experience architects. And in that job, he helps all of our customers kind of architect around the best practices in some of the largest and most complex cloud platforms in the world today. So we're really fortunate to have Ringo's experience here and him sharing some code with some examples using Go and GCP. Ringo, I'll let you take from here.
Thank you, Matt. So before we dive in, let us help you out. So participation on this workshop is always possible. So you can join our Slack and head to the workshop channel. So that's the community Slack. You can follow along if you go to the URL here. Matt, if you could copy that to the channel, maybe to the chat of this workshop, that would help out the attendees. And with that, I would say, let's get started. So in this workshop, I'm gonna show you how our multi-language aspects also help out with building components in one language and consume it in all of their other languages. Now, yesterday, if you attended the overall presentation by our management, you have seen that we announced GA support for YAML. So in this workshop, I'm gonna build a component in Go, build it into a single plugin binary, and consume it from our language, YAML language support. Now, with everything Pulumi, of course, we need an account. So if you haven't one yet, you can create a free account for personal use. Go to the bit.ly link on the slide, and from there, you can sign up and have all your cloud state stored on our Pulumi service. So what will we build today? So I'm talking about a Pulumi package. You heard me saying plugin, but what does that actually mean? So to give you an idea what we will building, I'm going to hook that up to our Pulumi architecture. So in our documentation, you've seen a picture sort of a bit similar to this. We have the Pulumi CLI in the engine in the middle. Typically, you have a language host, the language of your choice. And in this example, I'm going to use our YAML language host, and possibly in your application, one or more providers. Now, if you run a program, what's actually happening? Suppose you write in your Pulumi YAML file, you add the YAML constructs to create resources. But when Pulumi runs and asks the YAML language host to interpret that YAML program, every time it finds a resource, it sends a register resource request over a gRPC connection back to the engine. At once the whole program has been executed and our engine has received one or more register resource requests, at that moment, our engine calculates what it actually needs to do to fulfill these requests. So it takes the state, and it calculates sort of a difference. And based on that difference, it generates a whole series of steps. So suppose this is our first run. So at that moment, we do not have any state yet of existing resources. what our engine at that moment does is it sends create requests to each of the providers in use, for example. And in this, I'm sort of mimicking one GCP resource which needs to be created and one Kubernetes resource which needs to be created. So then the providers goes to work. They talk to the respective APIs. So GCP provider talks to the Google Cloud API. The Kubernetes talks to the Kubernetes control plane. Now, this is quite clear if you're just using a simple program, yeah, and in whatever language, and you're creating simple resources. Now, if we are building a Pulumi package and we want to consume that from another language, the situation is a bit different, but on the other hand, still similar. So what happens with the Pulumi component package in the picture? Where does it fit in? So in case of multi-language components, Pulumi packages, in a way, we also use the provider model, the plugin model. Yeah. So everything in a way in Pulumi is a plugin. So even on our language host, these are also plugins. These are language plugins. We have provider plugins, we have component plugins, and some of these can even be mixed. I'll come to that later. So you're used to working with the raw providers, which create single resources. But if we build a component makes us an abstraction of one or more child resources. So if we then put the instantiation of a component in our YAML file as a replacement for all the whole series of single resources, between the language host and the CLI engine, there's not much difference. Yeah, it still does a register resource request, but with all the metadata which comes along, there's also the indication that it's a component. Now, our engine then resolves based on the resource type, and I'll explain all of that when we go to the coding part. But at that moment, the first thing happens is not to create, but our engine will start our Pulumi CED components plugin, and it will ask to construct that component. Yeah, so that enters our plugin binary, and the only thing we do is sort of fulfill that by expanding the component and creating all the necessary child resources. So we just instantiate all the child resources like you normally do when you would be coding in Go. Yeah. And that in the end just sends register resource requests back to the engine. With the only difference is that we set a parent link to the component. That's the difference. But our engine still calculates based on the state. Okay, I had a component. It has two child resources, for example. Are these child resources already created? If not, again, do the same create calls to the providers. And then in the end, after a run, all of the state is saved on the Pulumi service or in your own self-hosted backend. So this is a bit the setup, how multi-language, how Pulumi packages fit into the architecture. So we sort of reuse all of these concepts for your own abstractions. Yeah. Don't make that abstraction, the distinction between a provider having only single resources and a plugin only having components. Given that it's all the same gRPC protocol, it is even possible to develop a Pulumi package, yeah, which has a mix of single resources and components. We don't have a case like that yet, but technically there's nothing which would prevent doing that when implementing a Pulumi package. So I hope this sort of small introduction gives you an idea how and what we will build and how it fits in when you run Pulumi. So on to our coding part. So on the link that I asked Matt to copy, so the link to the code, I have a few lab folders. Yeah? And the first one is actually the lab one. Yeah? And that's the starting point. So what I did is I made a copy of that lab one folder and named it the components folder. And that's actually the content of that file. So at the root level, yeah, you have a make file, typical license file if you want to open source it, git ignore file, a README file, but the most important part is this schema file. I stripped it down in a way to the bare minimum. And let's go over what is already here. To create a Pulumi package, each package should have a name. Yeah? And the name will come back in every of the resource types. And this name and resource types is also what is sent back and forth between all the different components in the Pulumi architecture to make everything of our multi-language setup work fluently. Yeah. So this name is one which should be unique amongst all of the possible plugins, packages you use. So bad idea would be to name it GCP because we already have a GCP provider. Yeah. So most often pick, for example, your company name. Then I have a whole section of language settings. Yeah. And you see subsections for each of the different languages we support or ecosystems we support. YAML is not in here because for the YAML, we do not need to generate the client SDK. Yeah. So every of the subsections in here sort of steer how the client SDK are generated for the multi-language aspect. So today we are building a package in Go. That was the right side of our slide. But if you want to consume that with other languages besides Go in your own preferred language, we have to create client libraries for that so that you have the full coding assist with code completion and all of that. By the way, Javier, normally that workshops repo should be public, if I'm not mistaken. So coming back to the component we are going to create, I'm going to take an example which might be useful even after this workshop. So if you're onto Google Cloud and you're using Google Kubernetes Engine, you might have heard of workload identity. Workload identity is a secure way to run your workloads and have the ability to, without needing to set static credentials, to allow your workloads to use and consume other Google Cloud services. Yeah. What's the trick here? Well, the trick in a way, and I have it open for workload identity. So the trick is that you actually need to create a service account in your Google Cloud project, and you have to create a Kubernetes service account and link these together. So that's actually what we are going to create as a component. Yeah? So I'm going to create a component named service identity in our own package, which creates these two components and sets all the required annotations between them to act as a correctly set up identity so that you can then deploy a workload which runs under which has the attached roles for the service account later on that on Google to allow you to consume additional Google services. So you heard me saying that we are going to set up Google services and Kubernetes services. So the first thing we need to do, if you later on, for example, would like to generate client SDKs, is that, of course, you need to add the required dependencies for the different language SDKs as well. Yeah. This allows to return types from the other packages without any problem. So in this case, I'm gonna add dependencies. And I'm locking them only to the latest major version of the provider. So this is something you have to take care of if later on you would like to generate the client SDKs, but we're not going into that aspect later on. Typically, there's not much problem here. It's all in the make file. So it's just running that and publishing these packages in general, but that's beyond the scope. Now, we have our Pulumi YAML. We defined what is in our language descriptor, but actually at the moment we haven't created or defined any resource yet for our package. So if we want to do that, yeah, that needs to be done in a resources section, similar to the language section. Yeah. So underneath here, we can create different resource types. Yeah. So in case we want to create our first resource, well, then we have to we have to pick a name for our first resource type. And you heard me saying that this name should be unique. Well, that means that in our resource type, that name has to return as well. Yeah. And every of the resource types is always a three-part identity, a type string. So the first is actually our package name. Yeah. The second is a module name. And given that it's all about identity and access management, I'm going to reuse the IAM module name. Yeah. And then this is the resource type name. So the full type name in the end is CED IAM service identity. This is also the type then that you will be using later on when we are going to consume the resource and that we will put in our Pulumi YAML file. What next? Well, the first thing actually is that we need to pass some information to it as input and output properties like any of our Pulumi resources that you might have used so far. So if we define, so thinking about it, what do we need? Well, we have to create a service account for Kubernetes, and we have to create a Google Cloud Service account. Now, creating a service account for Google Cloud is already bounded to the project, and setting the project is part of the provider configuration. So that means if I have a working provider bound to a certain Google Cloud project, I do not have to pass anything specific beyond the name. But for the name, I'm going to take the same name as my abstraction, as my component. So a name is not needed. For the Kubernetes service account, there it's a bit different. We have a connection to our control plane of Kubernetes, but the service account can be bound to a namespace. Yeah. So I'm going to say that the namespace, for example, is an input property. Yeah. Before I do that, by the way, I have to make sure that this component, this resource type, is actually treated as a component. And having this marker is required to identify between the create and the construct calls over our gRPC protocol. So coming back to the input properties, well, I'm going to create first the headings to set the input properties. And for the input properties, also have the ability to set which one are required. So you could have a resource type which has 5 different input properties, but maybe only 3 are mandatory, while the others are optional. So that means we can specify all 5 in the input properties and then mark the required ones under the additional section. How do we create an input property? Well, the input properties key actually refers to a collection. So the first thing we're going to do is define the name of our property. In this case, we need a namespace, so we make it namespace, and we have a small the camel casing for readability. Now, what type of value do we want? Well, typically a namespace is a string, so we make it a string. And then we can have an additional description. So this is the name of the namespace in which to create the Kubernetes service account. And given that we do want to pass an explicit namespace name, I'm going to mark this property as a required input. So with this in place, I have defined the service identity type, and I can pass inputs. Now, if we create our component, we still need to have, after the creation of the 2 service accounts, know what the IDs of these service accounts are. So besides input properties, I can as well define additional output properties, but it's not an output properties key, it's just properties. And similar to the required part for input properties, we can also indicate after creation of the component which output properties will definitely be filled in. So the properties and the required go hand in hand, and input properties and required inputs go hand in hand. So in this case, I'm going to define 2 properties, and the structure is very similar to the namespace I defined, but I'm going to create, I have the GCP service account and the GKE service account IDs as output properties, and these will definitely be filled in if the component is created. So hereby, I'm completing the setup of my schema. I hope that until now you've been following along. If you have questions, don't forget, do post them in the chat. I sometimes keep an eye on what's open in the chat, and I can sort of take some additional questions along during my talk. So given the schema file, we now have the schema with 1 component in it and the definition for the client SDK generation. Yeah. If you started from copying the lab and you were following along, or you prepared up front, then actually the make install provider should, oh, that's the wrong. So this make install provider should actually build successfully based on the minimal. And by the way, this minimal set of files comes from the boilerplate repository, which you can find in the Pulumi GitHub organization. So far so good. We have a schema file, but we didn't have actually made the backing implementation. So back that Pulumi CED components on the right side of my slide. So I'm going to close the schema for now and actually go into the provider implementation. And you see that I have a provider, but the only default that it has on a construct call is that it errors out because it doesn't know how to handle this. Yeah. So in this way, the first thing we want to do actually is to create the component itself. Yeah. So what we will do is in the provider, I'm going to create a new file and I'm going to call it service identity.go. Yeah. And with it, it's also, I of course prepared a bit of my code. So I'm also adding it to the provider package and I'm gonna set some of the imports correctly. So we will have to use Pulumi runtime, and I'm also gonna use service account from the Pulumi GCP Go SDK, and similarly for the Kubernetes packages. Note that these are exactly the same SDKs as are documented for each of the respective providers. So although we are building a Pulumi package, we are just using exactly the same SDKs, and there you see how even if you're using Go for simple resources, or you want to implement a component package using other providers, that's exactly the same SDKs. There's nothing special about. It's all the exchange over the gRPC protocol of different requests back and forth. So maybe I should reopen the schema file a minute and let's put it on the side. So I'm gonna save this here for a minute. So the first thing we need to do is actually map the properties onto Go constructs. Now, how is that done? Well, in Go, this is nothing more than a Pulumi, a component resource, as you can find in the component resource documentation. So if you see the component resource documentation, the first thing you have is an args type, a struct for the component itself, which actually extends the Pulumi resource state struct. Yeah. And you have a function, yeah, to create the service identity class. So typically in Pulumi, creating a resource is usually a three-part argument, with the only difference that the typical Go way is that a first argument, or in Go, is that you pass a context. Yeah. So in this case, every new call in all of our generated Go SDKs give 4 arguments, a context, then the name of the resource, the resource specific arguments, and the Pulumi specific resource options. So resource options are what you typically pass as setting the parent, passing providers, and so on and so on. So if you look at the template, what you then usually do is the first thing which usually happens is create an instance of service identity, and you register as a component resource exactly with that same type identifier as we had in our schema. Yeah. So every implementation of a resource type needs to match what was defined in the schema file. Otherwise, there's sort of a mismatch between what the schema exposes and what the implementation would offer. Going from here, yeah, we have the error handling, but we have to close it off with the formal component if nothing was wrong. So this is the minimal template which you can actually find in our documentation for a component resource implemented in Go. Yeah. Now, our arguments are not filled in while we mentioned that we have a namespace as input and we have two output properties, and these are not set on our component. So how do we do that? Well, the thing is that we are leveraging as close as possible to, we try to reuse, let's say, the best practices from each of the language ecosystems. And in Go, annotations, for example, are quite often used. So if we want to provide a namespace as an input argument, well, we capitalize it with so that it becomes a public property, publicly accessible property on the struct. The type is a string input. So typically, it's not exactly a Go string. But given that Pulumi works all with inputs and outputs, in this case, it's a string input, so it can be the pure string, or it can be an output from another resource. And then we use the annotation to map that onto the namespace property, which is exactly the same name as defined in our schema. So when Pulumi receives a construct request over the gRPC protocol to our plugin binary using these annotations, Pulumi, well, our Go implementation will know how to map that onto the structs which we will create when consuming, when wiring everything up. So this is for the input arguments. Now let's go over the output properties. Similar thing with the output properties. So we extend this, and here I'm saying setting exactly the same, but of course the type is different. We are now exposing outputs. So this is how you define the input, how you map what you defined in your schema into your implementation. The first thing which could happen is, given that we are passing a pointer to the service identity arguments, is of course that for the implementation, we check and we say, okay, given, in case we didn't pass the specific arguments, I'm going to create some defaults and use that following the call, the invocation rather. So here you see that if my args are nil, I create these args myself and I set the namespace to default, which is indeed the default namespace of Kubernetes. and we continue with the construction. So with this in place, let's see if my compilation already works. Well, I have yeah, so in this case, I have code which created the components, but I haven't added the dependencies yet. So I'm gonna download. Oh, wait, later on. I think I didn't add them yet. Oh, yeah, that's the point. So I have it added to my code, but I didn't add yet the dependencies to my Go module file. So I had so let's see. Oh, come on. Oh, yeah, that I need to do in the provider. And I'm also going to prepare the one for Kubernetes. So what I did so far is implement, let's say, the function, which will create an empty component. And I would like to see that working first. All right, so if I go back to here and I run my make install provider. Let me check what I missed here. Don't think I missed anything. That looks better. So for the moment, I have I made an implementation of creating the component, but I didn't add the resources yet. So as mentioned, we have to create a Google service account and a Kubernetes service account. I'm not going to go too much into the details of these, but after we registered the component, I'm going to create these resources. So here I have the Google Cloud Service account. Here I have the GKE service account. And you see that I had to I'm passing a specific annotation with the email from the Google service account. And this is part of what's needed for the whole workload identity setup. Now, you see that these are only local variables, GCP service account and GKE service account. So what we're going to do is yeah, we still have to wire these up to the output properties. Yeah, so this is, we created a component struct and we are setting the outputs to each part of the information from each of these components. And then a last thing, this is sort of an output in code, yeah, to make it accessible in Go. Now, if you want to have an output also exposed, so if you output the whole component as stack output, and you want these nested outputs to show up in the Pulumi web console, you also have to register them as resource outputs. Yeah. So this is what you do. These names are the names again from how you look at it, how they are defined in the schema file, and you set these to the actual values that we also set on the members. And with that, actually, our implementation is complete. Yeah. So far, so good. But you saw that the build is still failing. Part of it is because all that code hasn't been used yet. So going to the provider and adding here and wiring it up so that it calls the new service identity, it's I'm going to create a function with which I can actually map, I convert the generic construct inputs to my specific service identity arguments. So this is how all of our code that you will see look like. So let's go over this for a minute. I'm creating a construct service identity, passing the construct inputs. And here I create my service identity arguments. I copy them from these provider inputs to my specific arguments. And it's this function which will leverage the Go annotations to find out which value needs to be put in which property of my struct. Yeah, I do the proper error handling. And if I have proper service identity args, then I'm calling the new service identity creation function. And again, typical Go error handling. And you say as a result to the provider, here's the construct result. This is what I created as an outcome. Still, we miss the gap from here to here. Yeah. So in the type, I'm going to add a case statement. So not only the default, but if the type is CED IAM service identity on this construct call, then of course, I'm going to call the function below. And with that, I have actually, coming from an incoming construct call, I go to construct service identity, where I convert generic inputs to type-specific arguments, and I create my component. The component then creates all the child resources in here, sets the output properties, also registers them as outputs, and returns the fully constructed component. So let's see what that gives. Given that the error of below a Go reports on unused code, so given that everything is now in use, my installation worked, and you see that the last line here also installs it in the bin folder of GoPod, which is in my case under projects Golang. Yeah. So if I do this, I have this path added to my overall path. So if I do which Pulumi resource CED, I have actually a binary there, and this is the provider. And you need to have this in the provider. You need to have this on your pod for local consumption and local testing of your provider to work. Keep that in mind if you want to build also your own abstractions. So far, we have built the provider. Let's see if we can consume it. All right, now I'm going to close all of these files. I have built my provider, and I'm going to switch over to my consumer part. Again, typically what you see here is a Pulumi YAML file with the only thing which I did actually beforehand is running Pulumi new YAML. And the output gives you this Pulumi YAML file, and it asks for a stack to be created. Now, given that we didn't have any additional config, there is no stack config file yet. Yeah. So let's see how we consume that. So the first thing that I want to have is, and in this case, I'm assuming that I have a cluster somewhere built in another stack, which has outputted its kube config. So I'm going to use a stack reference, and I'm going to make the name to that stack reference configurable. Yeah. So the first thing I do is in my Pulumi program, I'm adding a configuration section, and I say that I require a stack reference of type string. Yeah. This means that every stack I create, I will have to fill in stack config for stack ref. The second property is, well, we are going to create our component. And as an input property, we said that we wanted to define the namespace. So for our stack, we're also going to say that a namespace must be defined. So far, so good. Now comes the actual program. Yeah. So we are going to add a resources section. And so, yeah, remember Pulumi YAML, all the YAML for our program can be put in the project file. Yeah. So contrary to the other programming languages where you put them in programming language specific setups, the YAML or YAML support can be put in line in the Pulumi YAML file. So the first thing we do is we are gonna create a stack reference to and to retrieve to be able to read our kube config file. Yeah. So that's the first aspect. Second is with that kube config, yeah, I want to create an explicit Kubernetes provider. So you see that the provider themselves are specific, are also handled as resources. The only thing is the type. All of our providers, let's say, in the end up with in this structure. Again, 3-part, but this is in the end. So if you would want to configure our CED provider, let's say, also specifically, yeah, then that would be CED as the 3rd part. So all of our providers end up with in this format. And as a property, I'm passing the kube config, and I'm retrieving the value from the stack output, also named kube config, from the GKE stack. Yeah. I'll show you in a minute. I already have a cluster running from another stack with an output property named kube config. So I'll show you in a minute. Given that we have a Kubernetes provider pointing with all the config pointing to the to our GKE cluster, well, I now want to create a component. So I'm going to say I'm going to instantiate our service identity component I'm gonna name it validate, just to validate that it works. Yeah, and I'm passing from my stack config the value of namespace into the namespace input property to my component. And that's it. Well, not exactly. If we would create a component like this, at this moment, it would fall back to the default providers. Now, we just created an explicit provider. So you heard me saying that every resource besides the service, a resource-specific arguments, you can pass any of the Pulumi specific resource options. So that's what I'm doing. Yeah. Given it's a component, we also have not only the singular provider key, which is normally not to be used in for a component resource, but I'm passing my explicit Kubernetes provider to the Kubernetes provider's resource option. Well, I could go on like this, and yeah, you would see that the components are the both component that the component with the service accounts will be created, but I want to do a bit more. I also want to test if my outputs work correctly, and I definitely want to check if the whole wiring between those two service accounts also work correctly. So what I did is I prepared also a workload to run with that service, with that pair of service accounts. So I'm preparing a deployment. Yeah, I'm passing in the namespace name so that workload runs in the same namespace as where the service identity is created, Kubernetes at Kubernetes level. And you see that as the pod spec, I set that I retrieve the created service account name from that validate component, and I set that as the service account to use for my workload. Yeah. And again, given I need to talk to my G-key cluster, this requires the explicit provider. I have my program, but I don't have my stack configuration yet. So for the time being, I'm gonna say, okay, let's create my namespace in the default namespace, and I'm gonna retrieve my stack configuration from a stack reference named like this. So if you see my stack config file, I have two properties. One thing is still missing. I have to also set the GCP project, and that is this one. So in this Google Cloud project, I have, this is my stack. You see the kubeconfig exposed as an output. This is actually my cluster, but without any workload yet. And what you see is, well, you see a list of service accounts, but no one named validate, which with a V, it should end up at the end. Yeah. Also, in my default namespace, I only have the default service account in that namespace, not my specific service account yet. So actually, now is really the time where everything comes together. And with the consumption, if I now run Pulumi up, we'll have to see what happens. Yep. Let's make the screen a bit bigger. Oops, have I made a mistake? Probably, you know. I had the whole file handy. Oops. Unknown required. Oh. I have written namespace somewhere with the lowercase p.
Give you a moment to search that out. Love it. The real demos are live here as we're building this stuff together. Really impressive use of the pieces of the system to assemble this stuff. It almost reminds me of building like Legos as you're putting this stuff together. And then what was really cool is how you address the YAML consumption. So Steve, you'd mentioned in the chat there, kind of. Or someone had mentioned in the chat, excuse me. Steve mentioned in the chat there about Python packages, building those, but then making them consumable in a different format. So yeah, fantastic, fantastic summary of what's possible here. The other thing that was asked here just in the chat was really about the decoupling of modules and ensuring and getting the different runtimes updated when components are creating the stacks. And so, that's really where Ringo is approaching right now as he's fixing this stuff up, of getting these things Pulumi'd up. And that Pulumi up will tell the state machine, what to go to do to bring the desired state up to the current state of Ringo's code in those modules. Are there any other questions that any folks have while we're coming here towards the end of the call? Make sure that we can get those answered as we begin to wrap up here, showing some of the final pieces. And I just got a chat asking if this is recorded. Yes, this is recorded, and recordings will be sent out thereafter as well. Ton to cover here, so yes, appreciate that y'all need to look at this a couple times to appreciate it fully, what Ringo's got assembled here. Oh, almost there. You got that. You made the point about camel case, and so it had to bite you, Ringo. It had to bite you.
Yeah, it seems like it. Okay, so let me find. Here.
Another thing to kind of talk about, in this idea of components and abstractions is that there's a composability factor here too. I said the buzzword. I said composability. As you create these different abstractions, these different packages, and you layer them on top of each other, component resources, multi-language components. And then, of course, you have to turn around and figure out how your consumers are going to consume them. A lot of what Ringo is showing here is some of the some of the authoring experience that you can put together to make it easier for people to build from the Legos. But another way that you can think of as enforcing a lot of this policy is more reactively. So as you're enabling more developers to build with the Legos and do different things, you can enforce the use of certain things, such as, a tag policy always needing to be applied to resources, for example, tag ownership to a business unit so you can show back the costs, or making sure that, different data residency requirements are followed with specific workloads. So lots of different ways then layer policy as code on top of these abstractions to ensure that even without code review, that the policies are being followed.
I have run this so many times before the workshop. I'm getting crazy. Oh, yeah, I think I found it. So, no, this schema file. Here it is.
Boom.
Boom. And then rebuild.
All right, big money, no whammies. Here we go.
The reason to rebuild the schema is because the schema is integrated as data in the binary. And that's how actually the YAML support knows how to, what types are supported, and to also support the code assist that actually, I think it was Luke who demoed that, that you could have for the YAML all the code assist. That happens based on the schema retrieved from the plugin binaries. Okay, back to the demo.
Nice.
Given with this in place, I would expect.
There
All right.
it goes. The drum roll proceeds.
So you see the stack reference, then the Kubernetes provider created. I'm creating my CEDIM service identity component with 2 sub-resources and a workload test. Let's go. So looking already on my cluster, so here my service accounts, if I refresh this page, you see the validate resource account created at the bottom. You see, oh, let me filter on the default name. Oh, default namespace. So here I have the validate, and Pulumi's auto naming was added to it. And if I look at my workload, I have my workload identity test deployment, and I have a managed pod. So let me check for once that workload identity. I used to have, okay. Okay, I'm copied over the kube config. So let's see. The consumer part. So let me, for again. What I will do now is I'm gonna go into that container. So here it is. And there's one thing I want to check, and I found that also in this. So it's a trick to verify if your whole setup works correctly. So I'm going to check from my container if using the metadata URL, yeah, if it gives me the indication that, oops, and this is different from the previous time. Am I using the correct URL? Create the pops. Oh no, I want to first see the email associated. Yeah, that's it. This was the. So to find the identity, so yeah, it's not without the new line, but here you see that this is the Google service account returned from a Kubernetes pod. So here you see that this pod, although it's attached, it's using a specific Kubernetes service account, that with that wiring, you also get automatically the identity of the corresponding Google Cloud Service accounts. And this actually concludes the creation and the consumption of building a Go-based component and consuming it in YAML.
Fantastic. Awesome job. Thank you, Ringo. Appreciate you fighting through with the demo gods there and getting that thing validated at the very end there. Really awesome. Thanks to everybody for attending. Appreciate you staying a bit long for the final reveal here and final validation. We'll stick around for a few minutes for any questions if you want to pose any in the chat. But also, you know, if you're looking to become a customer of Pulumi, you too can get access to Ringo for your own personal benefit. And so we'll throw that out there as well. We could certainly get Ringo on the phone with you to walk you through your specific implementations here and offer some guidance on how to create this composability. Thank you, everybody. Really appreciate it, and have a wonderful rest of the day.
Thank you, everyone.